Okay. So this is important to understand a little bit, to see that sometimes you end up with a situation in which maybe they miss each other, they overlap and they don't react. Or their behavior is kind of very strange. Like, for example, many times you're going to find that they stick together or they vibrate together, but it's like trying to separate, but they can't separate. And that will happen. The reason why is the following. Think about the fact that we have the radius of the radii of the two balls, because we're always thinking about pairs, being random. That's number one. Number two, velocities are also random, right? What else is random? Well, the position, if you want to avoid some issues that will be together at the beginning, right? They're next to each other. And then, of course, the distance is going to be zero and they will not be able to separate. Then I would suggest that also have a random initial position of the balls. So you can eliminate that problem. But what about the other behavior that I just mentioned before, in which they stick together, they bounce a little bit, but they then cannot separate? Well, that happens because we have a lot of randomness in all those things, like the radii, and the velocity. And so the distance, number one, can never be equal to zero. That's number one. If your condition is that if the distance is equal to zero, this distance, right? Which is the difference between the separation, the distance between the two centers of the origin of the circles, right? Minus the radius of each of them, that distance being equal to zero is most likely impossible, because the difference between two doubles could be 0.0001, and that's different than zero. So my advice is to think about a range. Like, for example, let's make it less than or equal to 0.01. And so maybe that will work. And the maybe comes from the fact that a lot of the stuff in here will be changing. For example, let me explain that. Let's say we decide that the distance is, if the distance is this distance right here is less than 0.01, then you have them bouncing. What happens if, in fact, the actual distance between these two is small, right? But remember, speeds are also random. So if that speed is smaller than the distance, the change of positions of those balls will be even less than the distance that you set to be, let's say 0.01. That means even after it made that change, after you changed the directions, after you did everything, this is still smaller than the value over here. That means that it's not going to escape. It's going to be trapped in there. So my suggestion is to play a little bit with it, display some of the variables. When does the distance become that you pick, right, is successful for most of the randomness behind this? So that's my number one suggestion. Number two, again, don't make it the distance equal to zero, because that will be almost impossible. Doubles, decimal numbers, will rarely become 0.00000. And there is a whole branch of things that you can, in computer science. As a matter of fact, when I was in college, one whole semester was designed for that, and the errors that doubles can actually bring about. So to do this really, really well requires more calculations, and all those calculations will be relative. They will be related to the randomness behind all this, and then you will have to use percentages. It will become very, very complicated. And that's not what I want you to do. All I want you to do is figure out the best D value here, that little tiny distance possible, because some type of reaction, meaning they know that they are near each other and they react in some way. And just changing the direction of the velocity is good enough for me. And even if it looks funky, it's all right. If they stick together for a few seconds and they separate, it will be okay too, all right? So think about the fact that there's so much randomness involved in all this that the distance should also be random and relative to the randomness involved, and that would make it too complicated. That's not what this is about. Okay, so anything that you can do to make sure that that D value is reasonable, that distance is reasonable, and in most cases, the balls will actually bounce, I will be happy. Also, you saw the video that I posted, that looks perfect. It's not really perfect. I found the right time in which the balls actually bounce well. So you can do the same thing, just record when the actual balls really bounce a few times, and that's it. You can always trim it when you open the video again. There is on the top in the edit a trim, and you can remove anything that you don't want to have it part of the video. Or you can leave it if you want to, because I will be looking for the optimal interaction between the balls. I hope this helps. I think those are the main things that happens in this. Oh yeah, one more thing. Make sure you use absolute values, because you don't want to end up with a distance that by accident it turned out to be negative. So make sure that doesn't happen. And one more thing is make sure that Rx, Vx have the corresponding values, for example, negative Vx and negative, and Rx is actually changing with Rx plus something, right? Make sure that the X and Y's are not the same. Sometimes you have Rx and the next one, instead of being Ry, is Rx. That I've seen it in multiple students. That's pretty much what you want to worry about this, okay? If you have more questions, it will make it useful for me to come up with short videos explaining some of the problems that might happen.